A century ago, Antarctic explorers were pushing further and further towards the coldest place on Earth, the South Pole, where temperatures can plummet to minus 80 degrees. The competition to reach this goal was matched by a less publicized but equally daunting scientific endeavor, the attempt to reach the coldest point in the universe, absolute zero. Was it possible to attain this ultimate limit of temperature, minus 273 degrees Celsius? Only in a laboratory, by liquefying gases, could scientific adventurers take the first steps towards this holy grail, a place where atoms come to a virtual standstill, utterly drained of all thermal energy. Among the front-runners in the race towards absolute zero was James Dewar, a professor at the Royal Institution in London.
It will be the greatest achievement of our age.
In 1891, he gave one of his celebrated Friday night public lectures on the wonders of the supercold to celebrate the centenary of his great predecessor, Michael Faraday.
The descent to a temperature within 5 degrees of zero would open up new vistas of scientific inquiry, which would add immensely to our knowledge of the properties of matter.
James Dewar is a canny and I think very ambitious, practically minded Scottish scientist. He could really show both his colleagues and the fee-paying audiences some of the secrets of nature.
Take this rubber ball. It bounces well, I think you'll agree. But let's see what happens after a few seconds immersion in liquid oxygen.
Dewar invented a thermal insulated container to carry out his research, and scientists to this day still call it a Dewar flask.
Now, let's see what happens.
This phantasmagoric aspect of science always helped science to be accepted by the public. Though it is a little mystifying, it did play a role of having society, having the public accept that these weird people in the laboratories are doing truly interesting, if not magical things.
Dewar's dream was to take on the mantle of the Royal Institution's greatest scientist, Michael Faraday. "70 years earlier, Faraday had done experiments showing that under pressure, gases like chlorine and ammonia liquefy. He was curious to see if this method of pressurizing gases into liquids could be used for all gases. But some, what he called the permanent gases, oxygen, nitrogen, hydrogen, would not liquefy, no matter how much pressure he applied. So he abandoned this line of research.
Faraday's was a mind full of subtle powers, of divination into nature's secrets. And although unable to liquefy the permanent gases, he expressed faith in the potentialities of experimental inquiry. The lowest point of temperature attained by Faraday was minus 130 degrees centigrade.
It was not until 1873 that a Dutch theoretical physicist, van der Waals, finally explained why these gases were not liquefying. By estimating the size of molecules and the forces between them, he showed that to liquefy these gases using pressure, they each had to be cooled below a critical temperature. At last he had shown the way to liquefy the so-called permanent gases was to cool them. Oxygen was first, and then nitrogen, reaching a new low temperature of almost minus 200 degrees centigrade.
Only the last of the permanent gases remains to be liquefied. Hydrogen, in the vicinity of minus 250 degrees centigrade. It will be the greatest achievement of our age, a triumph of science.
Dewar was determined to be the first to ascend what he called Mount Hydrogen, but he was not alone. The competitor Dewar feared most was a brilliant Dutchman, Heike Kammerlingh Onnes.
Kammerlingh Onnes was younger than Dewar, and to a certain extent looked up to the Scotsman as his senior. Dewar didn't have the same, if you'll pardon the expression, warm feelings towards his rival in the race for gold.
Dewar recognized that Kammerlingh Onnes had a new radical approach to science and was planning an industrial-scale lab.
When Onnes took over the physics laboratory in Leiden, he was only 29 years old. And, well, he gave his inaugural address here in this lecture room, the big lecture room of the Academy building of Leiden University, and it was all there. He was explaining what to do in the next years, and he was talking about liquefying gases, making Dutch physics famous abroad, and, well, it was amazing how far-sighted all those visions were.
Kammerlingh Onnes's lab was more like a factory. He recruited instrument makers, glassblowers, and a cadre of young assistants who became known as Blue Boys because of their blue lab coats. Later, he set up a technical training school, which still exists to this day. Dewar and Onnes could not have been more different. Dewar was very secretive about his work, hiding crucial parts of apparatus from public view before his lectures. Onnes, on the other hand, openly shared his lab's steady progress in a monthly journal. Onnes was the tortoise to Dewar's hare.
In the case of Dewar, you had a brilliant experimenter, a person who could actually build the instruments himself, and a person who really believed in the brute force approach, and that is, have your instruments, set up your experiment, and try as hard as you can, and then you'll get the results you want to get. In the case of Kammerlingh Onnes, you have a totally different approach. He is the beginning of what later on was known as big science.